All right, let's do a few assignment 5.3, few questions together. I'm just going to kind of skip around for timing's sake and kind of do one at each section. Or a couple in each section. Let's see. I'll do number 2. Okay, so when you see this integrand symbol, this means take the antiderivative. Then when you see these bounds, that just means you're going to plug those in at the end and subtract. So first, since this is squared, we're going to multiply this out. So 2t squared would be 4t squared. Multiply these together and double it. So 2t times 2 would be negative 4t, and then square negative 1, that would be plus 1. Now we're going to integrate this. That means add 1 and divide by it. So if I do that, that's going to be 4t cubed over 3 minus 4t squared over 2 plus t. And then normally we'd do the plus c if it was an indefinite interval, but it's not. We have these bounds. So I took away this integrand symbol and put this bar here to help me remember what my b and a are. So now we're going to plug in 4 for every t that we see. This would be just 2. 2 times 4 squared plus 4 minus parentheses. Now in this case, when I plug in 0 for all these t's, it's going to be 0. So I don't really have to worry about that. 4 times 4 cubed, let's see, 4 cubed is 64. 64 times 4, let's see, 4 and 4. So that's 256. Minus 16 times 2, 32. Plus 4. And so you can simplify this. I'll let you do that. All right, let's do this one. I'm just going to kind of talk through a few of these before I won't do all of them, but this one, make sure you rewrite it. So 3x to the negative 2 minus 1. So when you take the antiderivative, you're adding 1. So there's no shame in writing that down to help you remember what you're doing. 3x to the negative 1 divided by negative 1 minus t. And you're going to plug in the 5 and the 6. I would rewrite this as negative 3 over x. Oh, I switched my x's and my t's, sorry. Minus x from 5 to 6. So that's going to be negative 3 over 6 minus 6 minus negative 3 over 5 minus 5. Okay, and then you're going to carefully figure out what that's equal to. Be very careful. Again, when you put this minus, you're going to want to put parentheses around the second part when you plug in the values. So be careful to do that. This one you want to separate. So when you have a single term on the bottom, you separate it. That would be u to the 1/2. So then I can simplify this. 1 minus 1/2 is u to the positive 1/2 minus 2u to the negative 1/2. Then when you integrate this, you're going to be adding 1, which is like adding 2 over 2. So that'd be u to the 3/2 with the 2/3 in front, minus u to the add 2 over 2. So then that becomes 1/2, and then multiply by 2. So multiplying this 2 by 2, so that would be 4. And then if I plug in 9, 2/3, 9 to the 3/2 minus 4, 9 to the 1/2, minus parentheses 2/3 times 1. 1 to any power is 1. So those are just 1. Now let's talk about this 3/2 business. That's the square root of 9 cubed. The square root of 9, I like to make it smaller and then cube it. That's what this is. The square root of 9 is 3, and 3 cubed is 27. So that's 2/3 times 27 minus 4 times the square root. This 1/2 is the square root of 9, which is 3, minus 2/3, and then minus a negative would be plus 4. So this 3 and this 27, those simplify to be 9 times 2 is 18, minus 4 times 3 is 12, minus 2/3 plus 4. And so we can say 18 minus 12, that's 6, plus 4 is 10, so 10 minus 2/3, so that would be 30/3, minus 2/3, so 28/3. Just be really careful when you go to do that algebraic work. Let's see, I'll just kind of talk through again this one is going to be t to the 1/3 minus 6. So when you take the antiderivative, you add 1. So that's like adding 3 over 3. So to the 4/3, 3/4 minus 6t. And you're going to plug in both of these and subtract. This is not only just the square root of 2, but also the square root of x. So you can write it like the square root of 2 over the square root of x, which would be the square root of 2 times x to the negative 1/2. And so when you take the antiderivative of this, you're adding 1 to that 1/2. So that's like adding 2 over 2. So then that becomes x to the 1/2. And then you multiply by the reciprocal of this. You're going to have 2 root 2 in front, which is like an ugly answer in front. You have 1 and 36. So 2 root 2 and the x, x to the 1/2, that's the square root of x. So square root of 36 minus 2 root 2 square root of 1. Well, the square root of 36 is 6, and the square root of 1 is 1. So we have 6 times 2, that's 12 root 2, minus 2 root 2. And so if I subtract those, you can kind of treat this root 2 like an x. Like if I had 12x minus 2x, that would be 10x. So this is 10 root 2. Let's do this one, since sometimes I feel like that's a little harder for you guys. The cosecant. The antiderivative of 2 is 2x. The antiderivative of negative cosecant squared. So what is the derivative? What thing do you take the derivative of? And you get cosecant squared. That's cotangent, because tangent goes to secant squared. So cotangent goes to cosecant squared, but we're going the opposite way. And it's a C1, so I'm going to change the sign. So it's going to be a plus cotangent x from pi over 4 to pi over 2. So we're going to say 2 times pi over 2 plus cotangent pi over 2 minus parentheses 2 times pi over 4 plus cotangent pi over 4. These cancel, so I just get pi. The cotangent at pi over 2. We're up here, that's 0, 1. Cotangent is x over y instead of y over x, so that'd be 0. Minus, this is pi over 2. And then minus cotangent of pi over 4. Tangent and cotangent of pi over 4 are 1 because we have the root 2 over 2, root 2 over 2. So y over x and x over y are both 1. So I have pi minus pi over 2. So that'd be pi over 2 minus 1. Find the area bounded by the region. Let's do one of these. Here, I'll do this one. Okay, so when we find the area, I want you to graph this in your calculator. Okay, so you're going to go into your calculator, you're going to put that in y1, and it's going to look somewhat like this. And then x equals 1 is a vertical line. So we're not going to worry about this one over here. And x equals e is also a vertical line. So that's x equals e, that not e to the x, just e, like the number. So we're looking at this region right here, trying to find the area of that region. So we're going to be integrating from the left endpoint, which would be, sorry, it keeps popping up over here. The left endpoint, which would be 1, to the right endpoint, which is e, and we integrate top minus bottom. We integrate just this curve itself, which is 5 over x dx. Now we have to know that you can plot the 5 if you want to kind of see what it's going to be. When you see this 1 over x, that's special. This is a special integrand that you need to know, and it's natural log. So 5 natural log x from 1 to e. So then we do 5 natural log e minus 5 natural log 1. Well, the natural log of 1 is 0, and the natural log of e, these simplify to be 1, because remember, natural log of e to the x gives you back x. So this is natural log of e understood to the 1 power, so this just gives you 1. And so the answer for this is actually just 5. E to the x looks like this. Oh, x equals 0, x equals 5. So we're going to integrate from 0 to 5, e to the x dx. The antiderivative of e to the x is actually really simple. It's just e to the x. So e to the 5 minus e to the 0. E to the 0 is 1. So that one's a little bit simpler. Let's talk about this one. Okay, which one is? Okay. Let's do number 14 since that's a square root. All right, so find the values guaranteed by the mean value theorem for integrals. That is 1 over b minus a, the integral from a to b of f of x. Remember, it's kind of like the idea that you're summing up all the values and you're dividing by the width, and that gives you the average value of the function. So the average value of this function would be 1 over 9 minus 4. This is your a and b. You integrate from a to b, the function. So that's 1/5, and I could pull this 5 out front. 4 to 5 root x is x to the 1/2. So these actually simplify to just be 1 in front. Now the antiderivative, I'll change colors. The antiderivative of x to the 1/2, you add 1, that's adding 2 over 2. So x to the 3/2, put a 2/3 in front from 4 to 5. So 2/3, 5 to the 3/2 minus 2/3, 4 to the 3/2. This is not going to be a pretty, we're going to have to use our calculator. Okay, so at this point, you could go ahead and put this in your calculator. You could try to simplify this more. This is 2/3, and then that's like 5 cubed in the square root of that, minus 2/3, 4 cubed in the square root of that. So if you imagine that's like 5 5s in here. So you can pull out 5 times 5, you could pull out one of those 5s, and so it'd be 5 root 5. And the same concept here, you can pull out 1 4, so that's going to be 4 root 4. So we could say 2/3, and then it's 5 root 5 minus 4 root 4. That's what the average value is. Then we're going to set it equal to this function itself. We're trying to figure out where does this function actually equal its average value. Okay, so put this in y1, put this in y2, and figure out where they intersect. I'm going to see if my calculator will cooperate. I'm not sure if it will. Let me see. I'm going to take a picture of this so I can put it on my calculator if I need to, because I lose this. Trying to see if it's going to share. I don't know, guys. It's not pulling up my calculator. I don't know if you guys can see it, but I cannot. Let's see. Try one more time. Work. Okay, it's not working. I'm gonna go ahead and just pull my old school calculator. So I'm gonna put 5 square root of x. And then what was that? I think it was 2/3. 2/3, I think, yeah, 2/3. 5 root 5. 4 root. Okay, and I'm just gonna do standard zoom and see if I can figure out where these intersect. Okay, so I don't know if you guys can see my calculator. It's very old, but if you put in y1, you put the equation, and then in y2, you put the value, and then you can hit graph. And you can't really see my line very well because it's kind of broken across the screen, but there is a horizontal line going across here, and it intersects this one. The way you figure out where it intersects is you push second trace number 5, and then you hit enter 3 times. And then it tells you the value, which is 0.1798. And so what that means is if I was to do 5 square root of that x value, I get the average value of 2.12, which is the 2/3 5 root 5 minus 4 root 4. So that is how you do that problem. Let's go back to this. Okay, let's do one more. We'll do this one. Find the average function. Okay. So this one says, find the average value of the function over the given interval. So I can say 1/3 minus -3, -3 to 3, 9 minus x squared dx. You can do it that way, or if you know that 9 minus x squared is a symmetric function, then instead of doing -3 to 3, I could make it easier and I could just do 0 to 3 and double it, which is what I'm going to do. Okay, so or actually that would be just the total area. Anyways, you could double this area here and find the average value really along just the interval from 0 to 3. So let's do that instead. 3 minus 0, 0 to 3, 9 minus x squared dx. Okay, so if I take the because what's going to happen is it's symmetric, is this side looks just like this side. And so the average value of this entire function is going to work out that if you just took the average value of half of it, since they're symmetric, exactly symmetric. So 1/3, and then this would be 9x minus x cubed over 3 from 0 to 3. So then there's the 1/3, and then 9 times 3 minus 3 cubed over 3, and the 0 would just be 0, which is why it's easier to do that way. 9 times 3 gives us 27 minus 27 over 3, which is 9. And you're going to take 1/3 of each of that. So that'd be 9 minus 3, which is 6. Okay, so we get 6 as our answer. And then it says to find the values where it's equal to the average value. So that means where does 9 minus x squared equal 6? So add this over, subtract that over. So then that would be 3 equals x squared, which is going to be x equals plus and minus √3. And you can go ahead and make sure that makes sense. Like if you graph 9 minus x squared, and then you do the average value of 6, then you can do second trace, intersect, and you see that you get 1.73, which should be the square root of 3. Yes. Okay, so that's an example for how to do that one. I hope that helps a little bit as you do your homework. If you get stuck, please just do the Ask My Instructor, and I'm happy to help.